Alright, on this video I'm going to talk about graphs of polynomials, primarily about the change in the graphs, what the general form looks like, and the end behavior. So when you're talking about the end behavior, we're talking about a continuous graph, and continuous means that there are no breaks. So something like this, what is it end at x-wise? What does it end at y-wise? Okay, so there are no breaks in the graph. Okay, so this is going to go down forever to negative infinity, and this is going to go up forever to positive infinity. So that would be my end behavior for my range. For x-wise, this is going to continue forever to negative infinity. This is going to continue forever to positive infinity. And that would be my domain. So on continuous graphs, there's actually a rule that makes it very simple to tell just when you're looking at the function. So here are the rules. Even exponent. You have an even exponent and you have a positive leading coefficient. And remember that a coefficient is a number in front of your variable, and the leading coefficient would be the first number in front of the first variable, and that's assuming it's in standard form. So if you have an even exponent and a positive leading coefficient, the domain will go from negative infinity to positive infinity. The range will go from the vertex to positive infinity. And I'll show you how to find the vertices. That's just like our lowest point. On a quadratic, your quadratic's looking like this. So your domain is from negative infinity to positive infinity. Your range is from the vertex to positive infinity. Even exponent, negative leading coefficient, your domain is going to go from negative infinity to positive infinity. Your range is going to go from negative infinity to the vertex. It's hard to write one-handed. The reason for that is the negative leading coefficient is going to reflect it across the x-axis, so it's going to go like this. Domain still negative infinity to positive infinity. Range is now from the vertex to negative infinity. If you have an odd exponent, and a positive leading coefficient, and an odd exponent is going to domain still negative infinity to positive infinity. Your range, it's going to be negative infinity to positive infinity. Negative leading coefficient, domain still negative infinity to positive infinity. The range is now positive infinity to negative infinity. And that's how we're kind of looking at these. So, vertex, negative b over 2a, and you're in this form right here. And the function, whatever it gives you when you plug in the negative b over 2a.